Welcome to qnawire.
A temperature controller designed to work in a steam environment involves a bimetallic strip constructed of brass and steel connected at their ends by rivets. Each of the metals is 2 millimeters thick. At 20 degrees Celsius, the strip is 10 centimeters long and straight. Find the radius of curvature R of the assembly at 100 degrees. Okay, so this is a reasonably challenging problem, but let's get on with it. So looking at the thermal expansion formula for a metal, delta L, or for any substance for that matter, equals, so we're going to look at delta LS for steel, change in length of steel, is equal to alpha S, and we know that the change in temperature, so delta T, so alpha delta T, current length. So we know that our change temperature is 80 here, 80, and so multiplied by 80, and our current length, we're going to work in centimeters for the minute because it's just a little bit easier, times by 10. We know that alpha S, the coefficient for steel, is equal to 12 times 10 to the minus 6. And similarly, for brass, delta L B is equal to alpha B, so coefficient of expansion for brass, times by 80 times by 10. And we are going to say that our coefficient for brass is equal to 19 times 10 to the minus 6. And these units are degrees Celsius to the minus 1. And substituting in those numbers, sorry, that should be 80 times 10. There, sorry. And so substituting in those numbers, we get that, so we do, in order to get the length, we do LS plus, so 10 plus delta LS. It turns out that delta LS is equal to, so hold on, and delta LS is equal to is equal to 0.0096 centimeters, and delta LB, so the change in length of the brass, is equal to 0.0152 centimeters. So starting a new page here, that gives us the new length of steel, LS, is equal to 10.0, so this at 100 degrees, the length of the steel beam is 10.0096 centimeters, and the length of the brass beam is equal to 10.0152 centimeters. So now we need to think about setting up our simultaneous equations. So if we think about our bimetallic strip, the radius to the center of the strip plus 0.1 centimeter is going to, I'm just going to write it out and explain it as I'm writing it out. So our first equation is, so our equation for an arc is theta times radius plus 0.1 is equal to LB. So the length of the brass is the bigger one. So if we go to the center of our our bimetallic strip, we have, this is a much exaggerated drawing, but we basically have 3 radii here. This is the bottom of the strip, this is the top of the strip, and both of these here are 0.2 mil. So our radius of the strip is a center point here. So the distance from this center here to the center of the beam here, that distance there is 0.1 millimeter. So that's where we get radius plus 0.1 is to the brass strip is our radius plus 0.1 is LB, and our angle times radius minus 0.1 for, so arc length of the smaller one is equal to length of steel. So we have two simultaneous equations here, two unknown variables, fully determined system. We don't need to know the angle, we only need to know the radius. So to get rid of the angle, we divide, let's call this equation 1 and this equation 2. We do equation 1 divided by equation 2, which gives us r plus 0.1 over r minus 0.1, which is equal to LB over LS. Now doing a little bit of manipulation, algebraic manipulation, you can verify this for yourself. So multiplying through, taking some factors, we get that R is equal to minus 0.1, sorry, not minus, is equal to 0.1 multiplied by LB plus LS divided by LB minus LS. And it turns out that the answer to this is, so this gives us a radius of, so let's just move upwards here because there's no point going on to a new page just for the answer. So this gives us a radius of, and just double checking this on a calculator, that gives us an answer of about 3.6 meters once we substitute in all those numbers.